Today in geometry we're going to begin our discussion of space figures, and space figures, when they're talking about them, are really three-dimensional shapes. We're going to apply what we've done in the last several chapters, so we're going to apply what we know about area to eventually widen our description for surface area, and then eventually for volume. Now, to be able to talk about a space figure, that means we have to have this three-dimensional shape. So today we're going to talk a lot about vocabulary too. Also, we're going to talk about this idea called a cross-section. In other words, what a shape looks like if I were to do a slice out of it. What kind of shape does it look like inside based on the actual cut that I make? So let's hit on the vocabulary first of all. A polyhedron is a three-dimensional shape that has polygons that actually make it up. So for example, on this one you can see there's a pentagon on the end and some kind of rectangle or quadrilateral that go around the outside of the shape. All of those are polygons, which makes this a polyhedron. Now, a face is each one of these pieces that helps make up the shape. So this side right here would be a pentagon, it's one of the faces. This side up here that looks like a rectangle would be one of the faces. And I can go on and keep counting them if I wanted to. An edge is when two faces come together. So that would be this spot right here. That edge where kind of the top and the front come together. A vertex point is where three or more edges kind of come together. So that would be a vertex point. And I go around and continuously mark them all the way around. Now, on a shape like this, if they want us to list all the vertices. Now, vertices is plural for vertex. So sometimes you'll hear people say vertex or vertex point, or they'll say vertex points and vertices. So vertices would be all the letters that help make this up. So D, E, F, G, and H. Now, edges. Edges would be the actual line segments that connect two points together. So if I was going to go around and look at this, you can see in the bottom how it looks like there's some kind of rectangle, but if I went around, I would just have to list them. So GH, DE, FE, GF, and notice I'm using just my lines and marking them off as I go, just to make sure I don't forget any. The bigger your shape is, the easier it's going to be to leave something off by accident. Now faces. Let me get away from all these little lines that I made here. If I want to do faces, then I have to actually talk about the things that go together to actually make this shape. So I can see the bottom looks like some kind of quadrilateral. We said maybe a rectangle, but definitely a quadrilateral. So G, D, E, F would be that quadrilateral. Start at one point, go all the way around, listing all 4 points. Now on this, the other thing to be considered is all the rest of the sides are triangles. So the back side would be GHF. If I went over here next, it would be triangle FHE. Then the front would be triangle DHE. Then on this side, it would be GHD. Now you have to be able to go through and label all of them. That's really important. Okay, now, first of all, Euler, not Euler, Euler's formula has to do with the relationship that the faces, vertices, and edges have together. So if I know this formula, then if I know 2 of those 3 letters, like in this one I know my vertices are 10, and my edges are 28. So if I fill this in, I should be able to find the missing piece for F. So on this one, if I simplify this side right there, that's just going to be 30. So if I subtract 10, get F equals 20. That means up here where the faces are at, that answer is 20. Now a cross section. This is actually a piece from the book. On something like this, I want to think about this shape being a piece of Play-Doh. So imagine that I've made some kind of a prism here. Looks like an aquarium tank kind of shape out of Play-Doh. If I were to take something very sharp and cut a slice here, and I was to actually cut through here and open it up, they want to know what shape would be inside of there. So inside this, I can see how it would be a square from the way that it looks, but at least a quadrilateral. This one, if I cut this way and cut across, that would give me a triangle. So this cross section really wants to know what it looks like inside the shape if I were to cut it and pick up those two pieces and look. Now, a lot of these are going to do the same thing that we did before. You're going to have to make a list of vertices, you're going to have to make a list of edges, and then you're going to have to make a list of faces. Now, vertices are probably the easiest, just all the points that you have there. So A, B, C, D, E, F, G, H, I, J. So there's all my letters. Now, edges. Start at the top and kind of work your way around and then go to the bottom. So the top, if I started it, would be AB, BC, CD, DE, and EA. Those are all the ones here. Now let's do the bottom pentagon. So FG, GH, HI, IJ, and JF. So I've done the bottom now. My only thing left are the ones that connect the top and the bottom. So AF, BG, CH, DI, and EJ. Okay, now I just marked them off. Typically I do that in pencil so that when I'm done I can just erase it, but it helps me make sure I don't leave anything off. Now faces. The top and the bottom are pentagons, so those will probably be the two easiest to list. So I have pentagon A, B, C, D, E, and then the pentagon on the bottom would be F, G, H, I, J. Then the sides are going to be quadrilaterals. So I'm just going to make a list of quadrilaterals here. Just know all of the ones that I mark are going to be quadrilaterals here. So I probably would start right here where A and B are at and do that one. So A, B, G, F. The next one would be G, B, C, H. The front then would be H, C, D, I. Then I, D, E, J. And then J, E, A, F. Now listen, if you have a highlighter, you can mark them as you go. That would probably help you too.